Chapter 7.6 deals with general conic sections, and so the main thing that I want you guys to get out of this lesson is to be able to tell the difference between all four conic sections. And so we're going to do a few examples here. I've written down 4 problems, so if you want you can hit the pause button and copy them down. And I want to identify a few distinguishing characteristics between each one. The first one I'll let you know right now is a circle. And I was able to tell that because we have the same coefficients in front of my x squared and y squared. So notice how they're the same. I have an x squared and a y squared, and they're being added together. All right, so therefore that makes this a circle. How this is different than the next shape, which is an ellipse, is that we have an x squared and a y squared. They're both being added, and it's very similar to a circle, right? Except my coefficients are different. Oops, not same, different. They are different. And so that makes their rate of growth change. So whereas they were in the circle, they each have a growth rate of about 6, right? It's going to come out very even, versus the ellipse, it could either come out this way, a wide ellipse, or a tall ellipse. It's still circular, but it's not a circle anymore. Example 3 is a hyperbola, and that is because I still have my 2 squared terms, except they're being subtracted. Right? And the subtraction, basically, if you think of an ellipse, it basically turns the ellipse facing away from itself. Right? The subtraction symbol does that. Think about it that way; it might help. Number 4 is a parabola, and I could tell that because there's only one squared term. And in this case, since it's an x and a y squared parabola, it's going to be facing to the left, because we'll eventually have to subtract y squared from both sides. So that's basically the gist of the lesson. We just want to get right into some examples. Your homework is going to ask you to identify a conic section and then graph it. So let's do it. Okay, number 5. The equation is x squared plus y squared plus 4x minus 6y equals -4. Okay, right off the bat, that is a circle. Because remember, same coefficients in front of x squared and y squared, they're being added, and so this is going to definitely be a circle. So having said that, let's go ahead and rearrange this so that I can get it into its conic form. I'm going to leave myself a little bit of space right there for completing the square. I'm going to add the boxes, and the boxes get added to the other side as well. Inside the box goes a 2 and a -3, a 2 and a -3. My left side is going to be x plus 2 squared. My right side is going to be y minus 3 squared. And my right side is going to be 4, 9. Those cancel each other out. I have 9. And so what I have here, since I have a circle, I need to identify a couple of things. Remember, with the circle, we identify the center. In this case, it's going to be -2, 3, right? Because inside parentheses, things happen opposite your intuition. And the circle needs a radius. In this case, the radius r squared is 9, in which case the radius is 3. If I was to graph this really quickly, it would be so my center is at -2, 3, and I would move out 3 in each direction. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, and 3. Kind of a rough sketch. Whoa, not that good. Okay, hang on for a second. Let me pause real quick. All right, let's take a look at the next example here. Now this is a lot of mess. It looks kind of nasty, but remember, in a conic section, you only really need to pay attention to the squared terms. In this case, there are 2 of them. They are being added, and my coefficients are different, which makes this an ellipse. And so let's just go ahead and simplify this thing. So we get 8y minus 2x. And what I'm going to do is I'm going to move all of this stuff over to this side. All right, so all of that's gone. And at the same time, I'm going to add 11 to both sides. So that's gone. So all of this is gone here except the 11, so I'm going to go x squared plus 2x, leave myself some space, plus 4y squared minus 8y equals 11. Okay, before I do completing the square, I need to make sure my coefficient in front of y squared is 1. So I'm going to factor out the 4. I get y squared minus 2y, leave myself some space, equals 11. And that's going to be added to x squared plus 2x. I'm going to add the box on both, and I'm going to add the boxes here. Now remember, the second box is going to be multiplied by 4 because of this interaction between 4 and the box. So what I get is a 1 on the inside, a negative 1 on the inside here, a 1 and a negative 1. So let's go ahead and hash this out and see what happens. The easy part here is x plus 1 quantity squared plus 4 quantity y minus 1 squared equals, here comes the more complicated part, 1 squared is 1, negative 1 squared is 1 times 4 is 4. 11 plus 1 is 12 plus 4 is 16. So since this is an ellipse, it has to equal 1. I'm going to divide everything by 16. So what I get is x plus 1 quantity squared over 16 plus y minus 1 quantity squared over 4 equals 1. Now if I'm going to graph this thing, I need a couple of pieces of information. The center is at negative 1 comma 1, right? Opposite your intuition, negative 1, 1. A, the major axis, the longer one, is going to be 4. B, the minor axis, is going to be 2. And it doesn't seem to ask for the focus or the foci or anything, so I think that's all we need. So let's go ahead and import this graph here. And my center's at negative 1 comma 1. Oh, that does not show up very well. Change colors. Now we're in business. Okay, my major axis is underneath x, so it's going to move out 4 in the right and left side direction. So 1, 2, 3, 4. 1, 2, 3, 4. And it's going to move up 1, 2. And then down 1, 2, and it's going to look like that. Okay, let's move on to another one. In our next example here, we have this conic section. Now hopefully you'll be able to recognize it right away. This is a parabola, and that's because there's only one thing being squared. So let's go ahead and just hash this out. Given the fact that it's a parabola, the y is being squared, which means I need to move the 3x to the other side. So what I get, I'm actually going to write this backwards. It's going to be 3x equals y squared plus 6y plus 12. So now I'm going to do a little bit of completing the square here. This is 3x equals y squared plus 6y plus the box, right? And then I back 12 out here and I subtract the box because I want to keep everything balanced. So now I'm going to add 3 to both sides. So this is y plus 3 quantity squared. This is 9, so 12 minus 9 is positive 3. And that's 3x equals all of this. I'm going to go ahead and divide everything by 3. So I get, scroll down here a little bit, I get x equals, now y plus 3 squared over 3 is really 1 over 3 y plus 3 squared plus 3 divided by 3 is 1. So this is your equation for your parabola. Let's import the graph and see what happens when we graph it. Now, this is an x equals parabola, x equals y squared parabola rather, and because it's positive, it's going to face the right. And because it's a y squared parabola, we need to be very careful with how we deal with the vertex. The vertex in this case is going to be 1 comma negative 3. 1, 2, 3 down here. And it's going to open up a little bit wider because of the 1/3. That's not very wide. It's going to do something more like this. Okay? Let's take care of another one. Now, in this example here, we're going to go ahead and move 9y squared to the other side and 36y. And I'm doing that because I need you guys to identify that what we're actually dealing with, even though we have two squared terms and they're both positive, they're on the opposite side of the equal sign. What that means is that I have x squared minus 14x, that's ugly, minus 9y squared plus 36y plus 4 equals 0. Now, because I have an x squared and a y squared and they're being subtracted, that makes this a hyperbola. All right, again, two squared terms being subtracted, hyperbola. Okay, so let's go ahead and use completing the square on this thing. I'm going to subtract 4 from both sides. X squared minus 14x. I'm going to leave myself space. I'm going to factor out this negative 9. So I get y squared minus 4y equals negative 4. Right? It's got to be negative. When we multiply back in, we get a positive 36. I'm going to add the box. I'm going to add the box. I'm going to add the box squared. And I'm going to add the box squared. And that's going to be multiplied by negative 9. So let's go ahead and figure out what goes inside. Negative 7, negative 2. We get a negative 7 in here and a negative 2, and that's being multiplied. So inside I get minus 7 quantity squared minus 9 quantity y minus 2 quantity squared equals, well, this is 49 here. This is 4 times negative 9, which is negative 18. I just realized I made a mistake right here. 4 times 9 is not 18, it's negative 36. So when all this math is now done, I end up with 9. Let's go ahead and divide by 9 since we're dealing with a hyperbola. So what I end up with is x minus 7 quantity squared over 9 minus y minus 2 quantity squared over 1 equals 1. So let's identify everything we need to about the hyperbola. It centers at 7, 2. My major axis, A, is going to be 3. My minor axis is going to be 1. So let's go ahead and import this graph and see what this looks like. Remember, the major axis is underneath x, which means it's going to be a side-to-side hyperbola. So let's go over 7 to the right. 1, 2, 3, 4, 5, 6, 7. Up 1, 2. That's the center of the hyperbola. Let's go out 3 in each direction. 1, 2, 3. 1, 2, 3. And I'll move up and down 1. And instead of drawing the ellipse, I'm going to draw the box. The asymptotes intersect the boxes in their, or the box in its diagonals, and that was horrible. Something like that. And the hyperbola will generally look like this. Okay? Alright, I think that just about does it. We'll see you next time.